We have a second deduction in continuation of previous lecture. So the second deduction related to the second derivative. So we write down as x square del square u upon del x square plus 2xy del square u upon del x del y plus y square del square u upon del y square is equal to gu into g dash u minus 1, where gu is equal to n fu upon f dash u. So this is the second deduction. Now we solve some problems related to the Euler's theorem. So problem based on Euler's theorem and its deductions. So we start the first theorem, first question based on the theorem. So first question is that if u is equal to sine inverse x plus y upon root x plus root y, show that x del u upon del x plus y del u upon del y is equal to 1 upon 2 tan u. Okay, so here the inverse function is given. So when inverse function, that means inverse trigonometric function is given, so we cannot find the degree of the homogeneous function. For calculating the degree of homogeneous function, so we will rewrite this in this form. So that means u equal to sine inverse into x plus y upon root x plus root y. So we rewrite this as a sine u. Sine u is equal to x plus y upon root x plus root y. So this sine u we generally denoted as a f, function f. That means you can say that fu, the function of u. So we calculate the degree by using this thing. So that means this function. So how to calculate the degree? So we can take x as common from the numerator. So we write down as 1 plus y upon x. And from denominator, we take root x as common. So we write down as 1 plus root y upon x. So this gives us x raised to the power 1 by 2. And we can write down this is function of y upon x. So function upon y upon x. So this represents the degree n as we compare from the general formula. General formula says that when you have the function f in this form, x raised to the power n function of y upon x. So this is the homogeneous function of nth degree. So we compare this one. So here n is equal to 1 by 2. So n is equal to 1 by 2. So that means the degree of the homogeneous function is 1 by 2. Now, after calculating the degree, so we have a two way to solve this problem. One way is that when we apply Euler's theorem, so we solve this problem by using the Euler's theorem. So by using Euler's theorem. So when we use the Euler's theorem, so Euler's theorem says that x del f upon del x plus y del f upon del y is equal to nf. So here fu we represent the sine u. So just we replace this f by sine u. So here, so we write down as x del upon del x into f. F we have considered as sine u plus y del upon del y into sine u is equal to n into sine u. Okay, so we differentiate this sine u because u is the function of xy. So we differentiate sine u. So the differentiation of sine u is cos u del u upon del x plus y cos u del u upon del y is equal to n sine u. So we can take a cos u as common. So this gives us x del u upon del x plus y del u upon del y is equal to n sine u. So we write down this as x del u upon del x plus y del u upon del y is equal to n sine u upon cos u. So this gives us n tan u. So what is the n here? So n equal to 1 by 2. So we put the value of n here. So we see that. So x del u upon del x plus y del u upon del y is equal to 1 upon 2 into tan u. So this is our result. Now, when we want to follow the deduction, so by using the deduction, so we can solve this as by using the deduction. Deduction says that x del f upon del x plus y del f upon del y is equal to n f u upon f dash u. So n we have calculated as 1 by 2. So fu we consider as sine u and differentiation of fu is cos u. So this gives us 1 by 2 tan u. So here we solve by using the deduction.